In May of 2024, people in Florida looked up at the night sky and saw something that hadn't appeared there in over 500 years. A bright, shimmering curtain of red and green aurora stretching from horizon to horizon. At the same time, people in Hawaii, Jamaica, and northern India were seeing the exact same thing. Phones lit up, social media went nuts. And behind the scenes, inside NOAA's Space Weather Prediction Center in Boulder, Colorado, scientists were watching their instruments hit numbers they had never seen in their careers. The sun had just launched the most powerful geomagnetic storm to hit Earth in over 20 years, a G5, extreme classification, the first one since 2003. Nearly half of every satellite in low Earth orbit fired emergency thrusters to keep from falling out of the sky. 12 Starlink satellites didn't make it. And the entire North American power grid came within a few bad decisions of serious trouble. But here's the detail that everyone missed at the time. That storm, as insane as it was, barely registers compared to what the sun has done before. And what scientists are now finding locked inside ancient tree rings suggests that the sun is capable of something so catastrophic that it could send modern civilization back decades, not centuries from now, not theoretically. It has happened before, and the clock on the next one is already ticking. So let's talk about what's actually going on with the sun right now, what it's done in the past, and why some of the smartest people on the planet are quietly losing sleep over it. The sun operates on a roughly 11-year cycle. It swings between periods of low activity, called solar minimum, and periods of high activity, called solar maximum. During solar maximum, sunspots multiply across the surface of the sun, and the chances of massive solar flares and coronal mass ejections go way up. We are currently in solar cycle 25, which officially began in December 2019. And here's where this story gets interesting. Before Cycle 25 started, an international panel of scientists from NASA, NOAA, and space agencies around the world sat down and made their best prediction. They expected a weak cycle, a peak sunspot number of about 115, arriving around July 2025. Basically a repeat of the previous cycle, which had been the weakest in a century. The sun did not get that memo. By early 2023, sunspot counts were already running 12% ahead of the previous cycle at the same stage. By 2024, the numbers had blown past the upper boundary of every forecast model. In October 2024, NASA and NOAA officially declared that the sun had entered solar maximum, with a smoothed sunspot number of approximately 161. That's roughly 40% higher than what the best solar physicists in the world had predicted. And the flares. In 2024 alone, the sun produced over 50 X-class solar flares, which are the most powerful category. That shattered records going back at least 3 decades. An X 9.0 flare erupted in October, the strongest of the entire cycle and the 5th largest since 2005. And in November 2025, an active region on the sun triggered something called a ground level enhancement, which is one of the rarest solar events we can measure. Only 77 have ever been recorded. That's when solar particles are so energetic, they punch through Earth's atmosphere and are detected at ground level. Aurora lit up the sky as far south as Florida and Mexico. I mean, think about that for a second. The world's top scientists predicted a quiet sun and instead got the most active solar period in over 2 decades. Now, if you've been on YouTube lately, you've probably seen videos claiming the sun is about to do something it hasn't done in 12,000 years. Some kind of catastrophic solar cycle, a micronova, a civilization-ending event. And look, I get the appeal of that narrative. It's dramatic, it's scary, it gets clicks. But the actual science tells a different story, and honestly, the real story is way more interesting than the conspiracy version. The 12,000-year catastrophe cycle idea traces back mostly to a YouTube channel called Suspicious Observers, which promotes the theory that the sun undergoes a catastrophic micronova roughly every 12,000 years, shedding its outer layer and essentially roasting one side of Earth. There's also a group called Creative Society pushing similar claims. Here's the problem. No mainstream solar physicist supports any version of this theory. There is no established 12,000-year solar cycle in any peer-reviewed scientific journal anywhere. The longest well-supported solar cycle in the literature is the Bray-Hallstatt cycle at roughly 2,300 to 2,400 years. And solar micronova isn't even a recognized term in astrophysics. So where does the 12,000 years number come from? It's a distortion of real research. In 2004, a team at the Max Planck Institute for Solar System Research published a landmark study in the journal Nature. They reconstructed 11,400 years of solar activity using cosmogenic isotopes, basically chemical signatures left in ice cores and tree rings by cosmic rays. And their finding was genuinely remarkable. The modern era, specifically the mid-20th century through about the year 2000, represented the most active period of solar activity in over 8,000 years. That's a real peer-reviewed result. But 8,000 years becomes 12,000 in the telephone game of the internet. The Holocene epoch is about 12,000 years old, so references to 12,000 years of data get twisted into a 12,000-year cycle. There's also a 13,000-year orbital precession cycle that affects Earth's tilt, but that's about our orbit, not the sun's behavior. And here's the kicker. That exceptionally active modern period, it already ended. Solar cycles 23 and 24 were notably weaker than the mid-century peak. The sun isn't ramping up into some unprecedented superphase. If anything, it came down from 1. But that doesn't mean there's nothing to worry about, because the real threat isn't some made-up 12,000-year cycle. The real threat has a name, and it's been verified by actual science. If you're finding this fascinating, hit subscribe. I cover space and science stories like this every week. Alright, so here's where things get genuinely unsettling. September 1st, 1859. An English astronomer named Richard Carrington was in his private observatory sketching sunspots through a telescope when he saw something no human had ever witnessed before. Two patches of intensely bright white light erupted from the surface of the sun. He had just observed the first solar flare in recorded history. The coronal mass ejection from that flare reached Earth in just 17.6 hours. Normal transit time is 2 to 4 days. This thing was moving at over 2,000 kilometers per second. When it hit Earth's magnetic field, it triggered the most powerful geomagnetic storm ever recorded. The Deist index, which measures how much the Earth's magnetic field gets compressed, plunged to negative 900 nanotesla. The May 2024 storm hit negative 412. The Carrington event was more than twice as intense. The effects were wild. Aurora blazed across the sky as far south as Cuba, Colombia, and Hawaii. Gold miners in the Rocky Mountains woke up at 1 in the morning thinking the sun had already risen. Telegraph systems around the world sparked, caught fire, and shocked their operators. And here's the part that still blows my mind. Some telegraph operators discovered they could unplug their batteries entirely and keep sending messages using nothing but the electrical current the storm was generating in the telegraph wires. In 1859, the most complex electrical technology on the planet was a telegraph. Today, modern civilization runs on a global web of power grids, satellites, GPS networks, fiber optic cables, and server farms. Every single one of those systems is vulnerable to what the sun can throw at us. And we almost found out exactly how vulnerable in July 2012. On July 23, 2012, the sun launched a coronal mass ejection that was, by multiple measurements, as strong or stronger than the Carrington event. It was traveling at 3,300 kilometers per second, one of the fastest CMEs ever recorded. NASA's Stereo A spacecraft happened to be sitting directly in its path and measured what would have been a Deist index of negative 1,200 nanotesla. That would have exceeded the Carrington event. Earth had been in that exact spot just 9 days earlier. 9 days. That's the margin between interesting data point and global catastrophe. Daniel Baker, a physicist at the University of Colorado who studied the event, was blunt about what it meant. He said the July 2012 storm was in all respects at least as strong as the 1859 event. The only difference was that it missed. So what would actually happen if a Carrington-class storm hit today? Lloyd's of London, one of the world's largest insurance markets, ran the numbers. Their estimate for damages to the United States alone ranges from $600 billion to $2.6 trillion. Between 20 to 40 million Americans could face extended power blackouts. The reason is something called geomagnetically induced currents. When a massive CME slams into Earth's magnetic field, it generates electrical currents in any long conductor on the ground. Power lines, pipelines, railroad tracks. Those currents flow into high-voltage transformers and overheat them, potentially destroying them permanently. And here's the terrifying part. Those extra high-voltage transformers are custom-built. Each one weighs hundreds of tons. They take anywhere from 5 months to 6 years to manufacture and deliver. There is no strategic stockpile. A researcher at the University of California, Irvine named Sangeetha Abdujyothi, published a paper in 2021 warning about what she called an internet apocalypse. Undersea fiber optic cables themselves are immune to geomagnetic effects, but the electronic repeaters that boost the signal every 50 to 150 kilometers are powered through copper conductors. Those repeaters are vulnerable. A severe enough storm could knock out intercontinental internet connectivity for weeks to months. And somehow it gets worse, because a Carrington-class storm, that's not even close to the worst the sun can do. In 2012, a Japanese physicist named Fusa Miyake at Nagoya University was analyzing carbon-14 levels in ancient Japanese cedar tree rings. Carbon-14 is created when high-energy particles from space slam into nitrogen atoms in Earth's atmosphere. Trees absorb this radiocarbon and lock it into their growth rings, creating a permanent chemical timestamp of cosmic radiation levels going back thousands of years. What Miyake found in the rings corresponding to 774 to 775 CE was a spike of 1.2%. That doesn't sound like much until you realize that normal year-to-year variation is about 1/20th of that. This spike represented a solar particle event roughly 10 to 20 times more powerful than the Carrington event. It had been invisible to history because nobody was looking at tree rings for evidence of solar storms. She had discovered what scientists now call a Miyake event. And since her original discovery, researchers have found more of them. An event around 7,176 BCE, another around 5,259 BCE, both massive, both confirmed through multiple independent proxy records. But the biggest discovery came in 2023, when researchers analyzing subfossil Scots pine trees from the French Alps found evidence of a Miyake event from approximately 14,300 years ago. This one was roughly twice the size of the 774 CE event, and over 500 times more powerful than the largest solar storm recorded in the modern satellite era. Over 500 times. And it happened during a period of relatively low solar activity, which means these events can apparently strike at any time, regardless of where we are in the solar cycle. That's the kind of number that makes scientists very uncomfortable. Miyake events appear to occur roughly once every 1,000 years on average. They are not periodic, they are not predictable, and only about 16% of the available Holocene tree ring record has even been analyzed for radiocarbon spikes, which means there are almost certainly more events waiting to be discovered. A Miyake event striking today would overwhelm every protective system designed for Carrington-level storms. Satellite constellations would likely be destroyed. GPS and navigation systems would fail. Power grid transformers would be obliterated on a scale that no emergency response plan currently accounts for. Recovery could take a decade. So what are we actually doing about this? The good news is that governments are finally taking space weather seriously. NOAA launched its first satellite dedicated entirely to space weather monitoring, called SWFO-L1, in September 2025. It orbits at the L1 Lagrange point, about 1.5 million kilometers toward the Sun, where it acts as an early warning sentinel. And the European Space Agency is building something even more ambitious. Their Vigil mission, planned for launch in 2031, will park at the L5 Lagrange point, giving scientists a side-on view of the Sun-Earth line for the first time. That could provide 4 to 5 days of advance warning before a CME reaches Earth. Grid protection technology is also improving. During the May 2024 storm, devices called GIC blockers installed at US substations automatically triggered over 20 times, successfully stopping dangerous currents from reaching vulnerable transformers. Those devices work. The problem is that there aren't enough of them. The estimated cost to protect the 1,000 most vulnerable transformers in the United States is roughly $100 million. That's nothing compared to the trillions at stake, but the funding hasn't fully materialized. Current early warning capabilities give us somewhere between 15 minutes and 4 days of notice for an incoming coronal mass ejection, depending on how far out we can detect it. For solar flare radiation itself, there's essentially no warning. It travels at the speed of light and arrives at Earth in about 8 minutes. So here's where we stand. Solar Cycle 25 genuinely caught scientists off guard and produced the most dramatic space weather events in over 2 decades. The Sun spent most of the late 20th century in its most active sustained period in over 8,000 years. Miyake events prove our star is capable of eruptions hundreds of times beyond anything in recorded history. A Carrington-class storm narrowly missed Earth in 2012 by a margin of days, and our infrastructure is still dangerously exposed. The Sun doesn't need to do something it hasn't done in 12,000 years to threaten modern civilization. It just needs to do what it's already done before, and the question isn't whether it will happen again. It's whether we'll be ready when it does. If this video changed the way you think about the Sun, share it with someone who needs to see it. I'll see you in the next one.